Title of the first section today is Multiplying, Rational Expressions. In this section, we'll multiply rational expressions. Again, rational expressions will be fractions which contain variables. First question and first fraction, 7/3 times a second fraction, 5x/12. To multiply fractions, if you remember from previous sections, we do not have to have common denominators. We can just multiply straight across the numerators and denominators. The numbers or coefficients we can multiply. 7 times 5 would be 35, and the variable x we can put at the end for 35x. The denominator, 3 times 12, would be 36. Always check to see if you can reduce fractions or cancel any like terms. In this case we cannot, so our final answer is 35x/36. Second question, 5/3a to the second power times a second fraction, 8/a to the third power. Again, multiplying fractions, we can multiply straight across. 5 times 8 would be 40. And for the denominator, we have a single coefficient of 3, which will stay the same. A squared times a to the third power. If you remember from previous sections, when multiplying, we'll add the exponents. So 2 plus 3 would be 5. Again, checking to reduce fractions. 40 and 3 does not reduce. We only have a single a to the fifth. So our final answer is 40/3a to the fifth. And last question for the section. 2x/x plus 1 times a second fraction, x minus 1/3. Multiplying again, we can multiply straight across. One way to solve this problem would be to distribute, multiply 2x times x and 2x times a negative 1. For this section though, we want to reduce or cancel out fractions, so rather than multiplying when we have a binomial, we'll leave the 2x the same, and the x minus 1 we can leave in parentheses. The reason again for doing this, when checking to reduce fractions, you want to leave it in factored form, which would leave x minus 1 in the parentheses to see if it cancels out or reduces later on. The denominator, we have x plus 1 times 3. Taking the coefficient first, we'll put 3 out front. And again, x plus 1 is a factor that we can leave in parentheses so we can check and see if it cancels or reduces. Checking to see if we can reduce fractions. 2 and 3 does not reduce. We have a single x in the numerator. To cancel out the x, we'd have to have a single x. X plus 1 is different than x. And also x minus 1 is different than x plus 1. So in this case, nothing cancels and nothing factors. So our final answer is 2x times x minus 1/3 times x plus 1. Title of the last section today is More Complex Rational Expressions. In this section, we'll continue to multiply rational expressions. We'll have more complex questions where we'll be able to factor and reduce or cancel out fractions. First question is 4c over 2c plus 2 times a second fraction c plus 1 over c minus 1. In this question we have two fractions. Both fractions have binomials, which again means two terms separated by a plus or minus sign. Solving like we did before, we can multiply. When multiplying, we can multiply straight across, and when we multiply by a factor, such as c plus 1, we can leave that factor in parentheses. So the numerator would be 4c times c plus 1. For the denominator, we have 2c plus 2 times c minus 1. Before we multiply, we want to check and see if any of these factor. The first fraction, 2c plus 2, this one we can factor or take out a common factor. 2 divides into both numbers, so factoring 2c plus 2, we take a 2 out. Dividing by 2, we'll be left with c, and dividing by 2, we'll be left with a positive 1. So 2c plus 2 factors to 2 times c plus 1. Multiplying by a second factor, we can rewrite that c minus 1. So multiplying again, we can multiply straight across, factor when possible. When we have a single fraction and we're dividing, we can see if we can cancel any factors out. For example, the parentheses c plus 1 and c plus 1 both match up exactly, so we can cancel or divide those. For a final answer, we want to reduce when possible. We have the coefficients 4 over 2, or 4 divided by 2. 4 divided by 2 will be 2. We'll have a c left over in the numerator. And the fraction line, the 2 again, we divided. And we'll be left with c minus 1 in the denominator. So after multiplying, factoring, and reducing, final answer would be 2c over c minus 1. And last question for the section. First fraction is m minus 2 over 3m plus 9. Multiplied by a second fraction, 2m plus 6 divided by 2m minus 4. Again, multiplying, we can multiply straight across the numerator and denominator, and keep in mind any factors where we can factor those as we multiply. The first fraction, m minus 2, does not factor, but we can leave that in parentheses in case it cancels for our final answer. The second fraction, 2m plus 6, we can factor. Finding a number that divides into 2 and 6, that number would be 2. And dividing each term by 2, 2m divided by 2 will be left with an m, and 6 divided by 2 will be left with 3. So 2m plus 6 factors to 2 times m plus 3. Drawing the fraction line, the denominator, we have 3m plus 9. And again, factoring when possible, 3 and 9, we can divide each of those by 3. Opening parentheses, dividing by 3 will be left with m, and dividing by 3 will be left with 3. So 3m plus 9 factors to 3 times m plus 3. Multiplying the last denominator, or factoring, 2m minus 4. Factoring again, we can take a 2 out of 2 and 4. And dividing by 2, we'll be left with m. And dividing by 2, we'll be left with a negative 2. Once we have everything factored and everything written as a multiplication question, we can start to cancel out or divide out common numbers or factors. For example, if we have 2 and 2, 2 and 2 will divide out or cancel. Any factors in parentheses that we have in common, such as m minus 2 and m minus 2, exactly the same, they'll divide out or cancel. And we also have m plus 3 and m plus 3, both the same, which divide out and cancel. Looking to see what terms are left over, we have a single number 3. Keep in mind this 3 is underneath the fraction or in the denominator. The numerator, everything canceled out or divided out. But if you go back to the numbers we divided, 2 divided by 2, if everything cancels or divides, when you divide out, you'll be left with a 1. So our final answer to the question, after factoring and reducing, is 1/3.